Hello, Flat Earth researchers, debaters, and debunkers. This is a PDF that I was sent by someone called Acid Render. I don't know anything more about that person than the YouTube handle that they use to send this in a link in the comments section under my video about the angles to Polaris and how we see it because of perspective. And it's wonderful to have so much support on this issue that to me clearly demonstrates that perspective is the imaginary curve when we consider how Polaris appears to sink towards the horizon the further away we get. Obviously we're talking about a star that is very, very local. We are told in the heliocentric model that Polaris is something like 50 times larger than the heliocentric model's sun, and something in the region of 400 light years away. These are ridiculous numbers that have never ever been scientifically proven. They are just enormous numbers that are pretty much designed to blow you away and make it so unimaginable that you just have to accept it. But this model, for want of a better word, I hate using it, but this seems to be how people can understand it, is one of perspective with stars that are very close. Who knows how high above us they actually are? To be honest, it doesn't really matter. I've even had people demand that Polaris should change in angular size. This is the kind of ridiculous argument that anti-flat earthers will come up with. So to Acid Render and many of the others who have shown that they already see this as perspective being the imaginary curve, thank you very, very much. This is very important, and so I'm just going to do my best to share it and help get it out there so that hopefully other people can understand it from this slightly different way of presenting it than I have done. We all think and see things differently, so I'm hoping this will further illustrate the points I've been trying to make. So let's just go through it. It's not very long, but it does very beautifully illustrate what we see when it comes to getting further away from Polaris and it ending up on or close to the horizon by the time we get to the equator. There is absolutely no need for us to be on a curved Earth. Then we don't have to invent ridiculous physics to try and justify what we're seeing. So, of course, not to scale, it must be noted. In fact, there is never any illustration of the globe or otherwise that can really be to scale. So, for this is a true thing, a truism in life. We all agree that each person has his own small personal dome. Again, we're talking about this dome of perspective, and this is how we see the world. Regardless of whether you believe you're on a flat or a globe Earth, this is an undeniable fact of the geometry of our personal perspective. And it's a dome because we are on a surface. We actually have a sphere of perspective, but of course, being on the surface blocks everything off. So we only get a dome. Okay, so perspective is the appearance to the eye of objects in respect to their relative distance and positions. So just have a look at this illustration, let it sink in a bit. There is me, whoever you are, and the plane is above my head, and it is big. Okay, it's big for that person just above their head. My small personal dome. So they have their dome of perspective here, and that's you standing there, and you're looking at this aircraft directly above you. And of course, you someone else further away will see that aircraft as being much, much smaller. And they have their own small personal dome of perspective. Yeah. So the plane on this image is stationary, and it is above, as just like Polaris above the North Pole. So yeah, the aircraft is the same as Polaris above the North Pole, and me standing on the North Pole, looking up at Polaris. Okay, so someone far away from the North Pole will look at this at a different angle, of course. The closer you get, the higher up that angle becomes. Fairly straightforward. Page 2. So, let's just have a look at this. We have the lines of latitude here going from the North Pole, which is 90 degrees latitude, going down 80, 70, 60, 50, 40 down to the equator. It's obviously worth putting in 5 here just to get one more line in. So there's the equator, and then you can carry on south beyond the equator. So here, if you have your dome of perspective while you are standing at the North Pole looking directly up at the aircraft or Polaris, here is the plane from page 1. The plane is our Polaris. The North Pole is 90 degrees. Polaris is exactly above my head. Okay? Should be fairly straightforward. The dome of perspective looking straight up at Polaris. So it's there at, and we have the degrees labeled here as well, 5, 10, 20, 30, 40. So these degrees correlate to these degrees here. So we're going from 0 to 90 here and 0 up to 90 that way. Okay? Fairly self-explanatory. And we can see already that we've got these lines going, and we get this curve because of those lines. And of course, if you marked a line for every latitude and put it at a corresponding degree up here, a corresponding angle of degrees, so for example at 30 latitude, this line will be at an angle of 30 degrees from the horizontal, going up like that. So if we did one at 31, 2, 3, 4, 5, up to 40, we'd get lots and lots of lines, and they'd all go up there to eventually create what is a very smooth curve. Okay? Page 3. So now we Polaris to this observer with their dome of perspective is at an angle of 80 degrees. So you're on 80 latitude, and to look up at Polaris, it hasn't moved from its original position. We have moved, and so the angle at which we look up at it will be 80. So this is where it will appear to be. There really isn't much difference by the time you get up here. It all becomes fairly well squished together. So the difference in height here between these two aircraft, or where Polaris was when we were at 90 and 80, is not going to be really very noticeable. Alright? Again, not to scale, it's just showing you how it is. Okay, so now we are at 70 latitude, and we draw a line that is 70 degrees from the horizontal, and it reaches here. So the plane is placed right there. Perspective, the appearance to the eye of objects in respect to their relative distance and positions. Horizontal and vertical convergence. Polaris is at 70 degrees angle. Yeah? That's where it is. Alright. It seems it just is just following this pattern now. So we're moving south, it's getting warmer. So we're now at 60 latitude, and the line towards Polaris is 60 degrees from this location. So it now appears down here on this part of the scale. Again, it hasn't really moved, it's just because that is the angle at which we would view it from, because we've got further away. Distance makes a difference. Okay, let's read what it says here. Please remember about perspective, horizon, and vanishing point. Objects approach vanishing point. Objects approach vanishing point as we move away from them. Okay, so it's going to appear, Polaris or the aircraft is going to appear to be lower in the sky for us when we stand here at 50 latitude. The angle at which our line of sight will be to Polaris, which hasn't moved from its original position, will appear to be lower. It will be at 50 degrees. This is the observations we make. This is just really an illustration of reality, and it's on a flat surface rather than a curved surface. And it works because that's what perspective does. It makes things appear lower towards the horizon as we get further away, and that's what's happening. Okay? Page 7. Please remember about perspective, horizon, and vanishing point. Objects approach vanishing point as we move away from them. Okay, it's just repeating what's already been said, and of course the aircraft, or Polaris, appears now to be coming lower and lower in the sky. Although it hasn't moved, we have moved further south to 40 degrees latitude, so the line of sight that we draw to Polaris is 40 degrees, as it is in reality. Okay, now down to 30. So 30 degrees latitude, draw a line of 30 degrees above this horizontal, and that's where it is on this part of the scale, and that's where Polaris appears to be. Moving south, page by page, in perspective, objects become smaller and lower as we move away. Now, of course, we're not going to see much of a difference in the size of a light. Oops, okay. So demanding that the angular size change really isn't something we should do. It doesn't matter if you're going to say it's 1,000,000 or 1,000,000,000 miles away. You only have to imagine that it's much, much larger, so that we're able to see it at all in the first place as a speck of light in the sky. Okay. At 20 degrees, it's really getting low towards the horizon. So we're at 20 latitude, really getting close to the equator now, and we only have to look up 20 degrees above the horizon, which will be at eye level, to see Polaris, which again hasn't moved, itself hasn't moved. We haven't gone down a curved surface, we've just gone away in a straight line across a flat surface, and so the angle of elevation to view Polaris will be much, much lower. And here we are, almost at the equator. Due to perspective, Polaris is getting closer and closer to the horizon and vanishing point. Alright, 10 degrees, and it's a 10 degrees angle of elevation. Again, Polaris hasn't changed. Okay, we do see the aircraft here getting smaller because we're further away. Of course, in reality, we wouldn't see an aircraft that was that far away, but we're talking about lights in the sky. And here we've come down to 5 degrees, which is around where Malaysia is, just above the equator. Same for me too. Phuket is around here. We've even got Gem Beach Resort, DMS, degrees, minutes, seconds, coordinates, latitude N5, 27, 44.78, longitude east 103 to 4.88. Okay, a very precise location there. And we only have to look up from there at an angle of elevation above the horizon of 5 degrees, and Polaris will be there just above the horizon. Even though it hasn't actually moved, it's still where it was in the first place, but we have moved further away from it, so it appears to be lower to the horizon. Yeah. And here we are standing on the equator with our dome of perspective still. Polaris is less than 5 degrees above the horizon. Okay, moving south, we still would be able to see Polaris if conditions were perfect, in perfect conditions. Okay, so we're standing on the equator, and it's gone beyond 5 degrees now, so it's somewhere, it's pretty much down there. Okay, that is the end of the presentation there. Okay, it's excellently done. All it's doing is giving you the angle of elevation at which we do see Polaris in reality at these locations of latitude, and it's just across a flat surface. It's simply perspective. Of course, when they use the globe, they don't consider perspective. They turn perspective into a curved Earth. But the curve is here. Here is that curve. You don't need a curved surface because we already have a curve created by the difference in perspective as we move up, closer and further away. Yeah? It's really as simple as that. Okay? Perspective is the imaginary curve. So thank you very much indeed to Acid Render, whoever you are. You've done an excellent job, and I really hope this helps open a few more people's eyes to how we are seeing things in the sky due to perspective. Thank you very much.